Groundbreaking ideas in the field of science have recently been discovered today, as similarities between the electromagnetic and weak force have been revealed by scientists Sheldon Glashow, Abnus Salam, and Steven Weinberg, called the electroweak theory.
This new discovery reveals many characteristics between the two fundamental forces and their impacts between two protons. Under these two forces, all electricity, magnetism, light, and some types of radioactivity are subject to the electroweak force.
In today's segment of our daily broadcast, we have new information on the atomic structure. Protons and neutrons have been found to be made up of quarks, a type of subatomic particle. Maria Gelman considered quarks and other subatomic particles as elementary particles.
Recently discovered by Gelman, a quark has a fractional charge, which explains how protons and neutrons receive their specific charge. Gelman has received a Nobel Prize in Physics for his contribution and knowledge for the subatomic particle.
It has been constantly theorized by physicists that everything in the universe is made up of a few foundational building blocks, with their actions dictated by four fundamental forces. As of today, physicists have developed the Standard Model, which categorizes and brings a better understanding of how particles and forces relate to each other in the study of particle physics.
The Standard Model addressed the three types of fundamental force particles making up the components of an atom: fermions, which make up the matter; bosons, which carry the forces; and quarks. It also incorporates the three fundamental forces of the universe: the strong force, weak force, and electromagnetic force, which also excludes the gravitational force.
My feet hang on these chairs outside.
That's not like my neighborhood though. Sometimes I hear gunshots and it's...
Yo, you have to part.
Officially named and added elements 113, 115.
For those invested in the scientific advancements of our age, two new elements have been added to the periodic table. Flerovium, atomic number 114, has officially been added. It was created in the Flerov Laboratory of Nuclear Reactions in Dubna, Russia, about 10 years prior to this addition.
The second element to be added to the periodic table at this time is livermorium, atomic number 116. Livermorium was created in Lawrence Livermore National Laboratory in Livermore, California.
Scientists at CERN have confirmed the existence of the Higgs boson and the possibility of the Higgs field through their experiments using the Large Hadron Collider, a particle accelerator at CERN. The Higgs boson was first theorized to exist through research done in the 1970s concerning the development of the Standard Model. It was classified as an elementary particle that makes up an atom. It was believed to carry the forces within the atoms.
Development of the Higgs boson continued through the research done by theorists Robert Brout, Francois Embler, and Peter Higgs. They proposed a mechanism in which bosons and particles gain mass by interacting with an invisible field dubbed the Higgs field. The Brout-Embler-Higgs mechanism states that the more interaction, the more mass a particle gains. The Higgs boson is the associated particle to the Higgs field. Francois Embler and Peter Higgs received the Nobel Prize in Physics for their research on the Higgs boson and Higgs field.
As of today, IUPAC has officially added and named elements 113, 115, 117, and 118 to the periodic table after a 5-month period of review by the public. These additions mark the completion of the 7th row of the periodic table, a significant milestone for time to come.
These elements are nihonium, atomic number 13. It is the first element to be discovered in Asia. Found by Riken, a research group in Japan, it was named for one of the many ways to say Japan in the Japanese language, Nihon. Moscovian, atomic number 115, was found by the Joint Institute for Nuclear Research in Dubna, Russia, near the city of Moscow, for which it was named for. It was originally being petitioned by the general public to be named after Lemmy Kilmister from the heavy metal band Motorhead as Lemium.
Tennessine, atomic number 117, being named after the location of major laboratories that contributed to the discovery, including Vanderbilt University in Tennessee. Organesin, atomic number 118, was a collaborative effort between scientists in Dubna, Russia, and American researchers at the Lawrence Livermore National Laboratory. It was named after the Russian physicist Yuri Organesian, who made several contributions to the periodic table.